Now we'll move to Dr. Mohammed Al-Haj Hussein. He's our fourth presenter in the session 2. He's a consultant in green concrete and green buildings. He will talk to us about the utilizing natural pozzolan in green concrete, green buildings, and sustainable development. Dr. Mohammed, we are happy to have you with us, and the floor is yours. Mohammed, you can remove the mic, the mute. حاول still there is a mute in your mic. Can you?
Okay, now you have it?
Yes, you can hear, we can hear it.
Okay, and you can see the screen. Okay, Assalamu alaikum. Bismillah wa salatu wa salam wa rasulullah. I'd like to thank Engineer Salim Ajami and all the speaker and organization that Arab Union had made for sustainable city. Natural pozzolan and green concrete, green building and sustainable city. You can see lava from thousands of years. We can make green concrete building using that lava. We have many Roman construction from 2000 years. Here, if you can see to the right, Hoover Dam and the Colorado River, it's built from 931 to 936. It was the first one who used natural pozzolan or lava in the dam to reduce heat of hydration to make a green concrete. Around 550,000 cubic meter of green cement. In Jeddah, alhamdulillah, we made the first green construction in 2008. The project was stopped for 6 months because they are looking for green cement. When we apply the green cement, more than 550,000 cubic meter of green cement, and the net profit for the ready-mix concrete was 28 million riyal to use green cement. What is the natural pozzolan? Type and color. Natural pozzolan and green concrete, the Roman construction since 79. Why do we need green concrete in Saudi and Gulf? The cost of corrosion control in Saudi and Gulf, around $50 billion a year. What the environment impact of cement production and the Paris Agreement? Lava mountain in Saudi Arabia and USA and the world. Natural pozzolan and green concrete in USA and Saudi Arabia. And there is some Dubai regulation for green building and green concrete. What is natural pozzolan? Natural pozzolan are typically produced by volcanic eruption, consisting of silica and aluminum oxide, key ingredients for green concrete. You can see this like here, if you can see it. Lava. We have around all the world. This is the green concrete types and color. Here we have the magma from 200 kilo or 1000 kilo from underground coming to the ground, volcanic ash, volcanic rock, and they call it natural pozzolan. According to Quran, there is 3 kinds: white, red, black. The best one is white, and then red, and you can see the black one. We have black and red in all Arabic country, Middle East. White one we have in Turkey, Greece, America, Canada, and South Asia. This is the one who have pozzolan powder in his hand. This is from Greek. It's applied from 3,600 years. This some cement factory in Yemen. They make limestone, clay, gypsum. If you heat it together, you will have OPC cement. If you replace some of OPC cement with pozzolan, natural pozzolan, you will have green cement. So why we call it pozzolan? Because of deposit of volcanic material near Pozzuoli, Naples, Italy. So we call pozzolan because of Pozzuoli. The first source of natural pozzolan, pumice or ash or tuff. It was formed explosive volcanic eruption, Mount Vesuvius, Bombi, and the other. Example of natural pozzolan like volcanic ash, tuff, pumice, shale, and domatic earth. So natural pozzolan we can get it natural raw material, or we must heat it to make active pozzolan. Sometimes we grind it or heat it or drying. So pozzolan, a silicate aluminum material. It's not cement material, but with cement, with water, it can make very good calcium silicate, aluminum hydrate, and we make green cement. So Roman had used it in natural pozzolan. They use it in green construction in Libya, in Syria, in Lebanon, and Scotland, in different countries. And more than 2,000 years now, still Roman building still standing. This some Roman building, calcium and Pantheon, is from 2,000 years. They use around 70% pozzolan, 30% lime. So the secret key ingredients for the Roman sustainable structure is natural pozzolan, volcanic ash. They put it with they have silica and ammonia. They combined chemically with lime. They make pozzolanic cement. When we make it with water, it have now green concrete. So natural pozzolan, the secret mix was third lime powder, 2/3 pumice powder, 3% admixture. So this is my book 2003, and this is my article magazine 2008. And in the picture of book my PhD, you can find a Roman building in South France from 2000 years, built by the 70% pozzolan. So in the book, I said the 70% pozzolan will have best over quality, durability, better performance than Morten cement. The book will help corrosion control, green building, and sustainable development. We are lucky that the Saudi Building Code 2018 and ACI Code 318, they include natural pozzolan in the durability of concrete. And this before Paris Agreement. Paris Agreement need to reduce carbon emission. We can reduce 30% if we use pozzolan. If you check the website of US Green Building Council, you find my book about green concrete and green building. What is green cement? What is green concrete? Why do we need green concrete, green cement, and Saudi anchor? So we have now, you can see aggregate, sand, cement. We can make concrete with water. We have now Portland cement, 41% crushed stone, 26% sand, water. If we replace some cement with pozzolan, we can make it green cement. So some people said green concrete means green color, but it's green in the environment aspect. So what we'll do with the green concrete, we can replace some of cement by pozzolan. We have long life cycle, durable, sustainable, save maintenance, energy saving, reduce CO2 emission using recycled and treated water. So OBC concrete and green concrete. OBC concrete have 100% cement, 0% pozzolan. Surface life is 5 to 20 years. Well, green concrete have 15 to 70% pozzolan, 15 to 70% cement, 30 to 80% pozzolan. We can get surface life 50 to 100. OBC cement and green cement. OBC cement have 100% cement. Green cement have 0% cement. The green cement have a lot of pozzolan, and OBC cement no pozzolan. Surface life, OBC cement 5 to 20 years. For green cement 100 to 5,000 years. Pyramid had used green cement 5,000 years. Roman had used it for 2,000 years now. Yeah, this is my this abstract in Qatar and Kuwait. How we can use the lava like Roman, and then we can use it in Roman concrete. USA had used it for 100 years, many projects, and we have a lot of corrosion, around $50 billion every year in Saudi Arabia. We have around 100 million tons of CO2 emission every year. So I said in the map, we have around 90,000 square kilometers in lava. We can use it in green concrete, green building. And this is the building here. You can see green concrete, green building, green filling, all using natural pozzolan. This is my idea to the world, to use world lava in every country. So local natural pozzolan in concrete worldwide, reduce cost of green construction, reduce corrosion and duration, improve durability and sustainability. Many countries around the world have volcanic mountain using local pozzolanic material. We have more than 800 areas in the world. So we can reduce building cost, protecting health and reducing environment pollution in less developed country to get the stable development. So what the environment impact of cement production? And we have 6 to 8% global carbon emission. in Saudi Arabia and in the world. So we have Morten cement produced in developed country. Byproduct, we can have carbon dioxide and some pollutant and some harmful material to the environment. So in Saudi Arabia, 17 cement factory, they are producing 60 to 70 million ton of cement per year, emitting 90 to 100 million ton of CO2 emission, which is very bad for Paris Agreement. So if we make 25% of local Boslan, we can lower building costs and reduce pollution by 25%. We can save 25% of cement and clay and fossil fuels and energy consumption. We can reduce 25% of carbon emission by using only 25% of local Boston. Reduce carbon emission in cement and concrete will help us in climate action plan worldwide to the goal to meet the goal 2016 Paris climate change agreement. Now in Dubai, mashallah, they are using 70% Boston on all the projects, important Boston. Saudi Arabia, some projects are using 60%, but we try to use local Boston. So national Boston in Saudi Arabia and the world in health, in agriculture, environment, adopt Paris Agreement, increase green economy, achieve sustainable development by Saudi Vision 2030. Also, we can make it using the world Boston to get world Vision 2030. Why do we need the cost of corrosion in Saudi and Gulf, $50 billion a year? The annual cost of corrosion and concrete repair around the world, hundreds of billion. In USA alone, around $400 billion a year. They through salt, sodium chloride, then we have a lot of corrosion in the car and the road. When the main green solution to our problem in many countries in the world use local Boston and green concrete, green building to improve corrosion control. This in Kuwait, I will thank Kuwait Research Center in 2002, but they said it will increase 15%. Now, in Saudi Arabia, the highest, corrosion rate, and then Emirat. But now, alhamdulillah, Emirat stopped in Dubai from 2008. They stopped use OBC. They are using only green cement. If you don't use green cement in Dubai, you go to Sharqa or different country. In Saudi Arabia, it was 13 billion, now around 40 to 50 billion dollar a year. This from 2008, I wrote in the newspaper, please make green concrete to stop corrosion, in Saudi Arabia. And this with the Anti-Corruption Committee in 2013, they found 90 minutes workshop that the green concrete, green building can save a lot for the government. In Yemen alone, it saved 4 billion riyal using national Boston in Yemen. So our aim in Saudi Arabia and to stop using fly ash from outside, from India or China, we must use our local Boston in our country. This is my book here. Why do we need green concrete? Green concrete with local Boston replacing around 25% of Boston can provide performance, corrosion control, and cement efficiency. Using national Boston, concrete producer, contractor, specification for green concrete, using green concrete can help sustainable development. So national Boston can give us green concrete, we have stormwater management. This one will save 50% of water in sand, reduction CO2 emission, using renewable material or passive solar, heat island effect and efficiency, water efficient, water technology, replacing other resources. We must use local material. So using national Boston and green construction, save energy, improve indoor healthy environment, reduce sickness, increase productivity time while protecting the environment. So using green building can reduce corrosion, deterioration, and improve durability and sustainability of concrete. Protect health and reducing environment pollution in less developed country is more important goals in sustainable development. So if we have time, we can show some lava map here in Saudi Arabia. This around 2,000 lava mountain in Saudi Arabia, 90,000 square meter. You can see here the project of Amala, Neom, and Red Sea project, but they are not using local Boston, they are using imported Boston. So this, if we can use local Boston in this project, we can save a lot. So according to Crown Prince, said in 2020, we can get 90,000 green job and $25 billion from using local mines. So I suggest for many projects in Saudi Arabia to use Neom project, Amala project, Red Sea, using their local Boston. This in Akhal area, this in Medina, this in Medina. Also Medina, different color. In Ha'il, black and red. Here, red color. We have in Khraibet, this is the best photo by Nasser, that we have white and black at the same time. So thank you. I have one more photo if you have time. Okay, thank you.
Thank you, Dr. Mohammed Al-Haj Hussein, of talking about green concrete and the green building. Sure, we will have some discussion during the panels. And now we'll move to our fifth speaker in session two, Mr. Mohammed Munamni. Can you stop sharing? Yeah. Mr. Mohammed, he's managing director of Green Urban. He will talk to us about the future role of hydrogen in powering sustainable cities. We are glad to have Mr. Mohammed with us in this webinar. Mr. Mohammed, the floor is yours.
Thank you, Dr. Salim. I'll just try to see if I'm able to share my screen with you.
I think we can see it, but this is not the first page, I think.
Yeah, for some reason the slides are.
Yeah, you can stop sharing and share again. Yeah, but make sure you open the first page first.
I hope my screen is clear now.
Yes, now we see it. Yeah, it looks great now. Yeah.
Yeah, thank you everyone for this very interesting webinar. For all the speakers, thank you for Dr. Salim for providing me the opportunity to speak on this session. Myself, a quick introduction. I'm a management consultant that we are focused on the advisory for sustainable infrastructure, financing, and public-private partnerships, along with economic impact of sustainable policies and infrastructure. So in our session today, I'll be talking about the future role of hydrogen power. We are talking here about the fuel of the future today. The fuel of the future, as one of our speakers, Dr. Mohammed, was saying that in 1979, the solar power per kilowatt was $70, $75, and now it's $0.5 today. So that shows how the price of future fuels and future energy can drop 100 times. Similarly for hydrogen, hydrogen is basically a gaseous molecule. It carries a lot of energy, but and it has a lot of potential. It is very much abundant around us in the environment, in the water, in the oil. So plenty of sources that we can get hydrogen from. The problem with it is that it has a high cost of extraction. It's hard to take out and it's hard to store. Its uses, it can be basically used in all the applications of fuel. So if we can use the fuel for transport, let me see if I can put my pointer. So if we can use the fuel for transport and power, we can also use hydrogen for that. We can also use hydrogen to heat our industries for and to heat our buildings and to cool our buildings as well. We can also use it as feedstock, as an ingredient in our fertilizers, fuel refining, plastics, fuel refining. This is already happening in the US. There is 70 million tons generated every year of hydrogen to help in the fuel refining process. Also, it's included in some products like wood and steel and glass. So the beauty about hydrogen, why we are focusing on a fuel that is more expensive than the current fuel, simply hydrogen has a lot of energy in it. When you combust it, it combines with oxygen, generating water. So instead of all these buildings and cars generating carbon dioxide, increasing the gases that trap heat in our atmosphere and increase the temperature of Earth, hydrogen is a very friendly fuel to the Earth and to humans. So that's really the future of fuel. I'll do a quick comparison here. There's many types of fuel. I will not bore you with the types of this hydrogen. It's based on how you generate it. So if you do electrolyzed water, you pass electricity into water, you break water down to its hydrogen and oxygen, and you get a clean fuel without emission of carbon dioxide. The blue hydrogen is you are pushing steam into the oil or the gas, and you're generating hydrogen and carbon dioxide. And then carbon dioxide can be captured so it doesn't pollute the environment. And it has a number of applications. There is the gray hydrogen, which is basically, it has the same process as the blue hydrogen, but it doesn't capture. You don't catch and trap the carbon dioxide. So you end up emitting some carbon dioxide into the atmosphere. And finally, the brown hydrogen, which also follows the same process, but it generates it from coal. Also, it's not as environmental friendly process. If we compare the cost of, I will focus here in the region, our Middle East, the most promising in the short term is the gray hydrogen, but really perhaps what we should be aiming for in the long term is the green hydrogen as the technology of hydrogen improves. We are now around $45 MMBTU, which means that we are 5 times, 6 times more expensive than the conventional fuel. And we're talking about hundreds of companies that are doing research and improving the cost of generating hydrogen, going down from 10 to 6 and now around 5. The efficiency in generating the hydrogen is decreasing, and the price is reaching $1 per kilogram, which is very competitive with our conventional fuel before 2050. Most studies are saying 2050, but we really believe this is going to happen with the pace of technological advancement. This could be happening really much earlier than that. Many countries are aiming high. Japan has included hydrogen in its country strategy. South Korea is also competing with Japan. They are directing all their education, their R&D, their manufacturers, especially the auto manufacturers like Honda, Toyota, and Hyundai, into the manufacture and improvement of the hydrogen car. So far, these are really the leading countries. The European Union, on the other hand, is trying to capture hydrogen, is improving on the extraction technology. So they are really working on the North Sea, generating power from wind, and wherever excess power is generated, they are, instead of storing it in batteries, because batteries has a limitation to how much energy it can store, they are now improving the storage of hydrogen, particularly because they have a gas network, existing natural gas network, which they can use for hydrogen. So they are utilizing the infrastructure smartly to transform into the new form of energy of the future. Canada is aiming at 27% of its energy use as in the form of hydrogen. US has already been extracting hydrogen, gray hydrogen, for its chemical and industrial sector. and many other countries are competing, in particularly Australia. So as we said, one of the advantages of hydrogen is that it really carries a lot of energy with it, much more than the lithium ion. The challenge is that you really hydrogen is really hard to handle. You need to cool it down to minus 250 degrees. You need to pressure it into very special pressure containers that applies 10 times the atmospheric pressure. And H2 is a very reactive gas. So speaking of reactivity and these challenges, scientists are coming up, and we have very good signals that of a new way to store hydrogen, which is ammonia, which is attaching many hydrogens to one nitrogen, and this requires less space, is less reactive, requires less cooling energy to store that form of energy. So we're really looking at ammonia as a new medium of energy. Why we have to understand these characteristics? Because we understand these characteristics, understanding it will allow us to understand what will be the shape of the infrastructure that is of the future. Like Saudi now is developing NEOM, is developing the line. Egypt is developing one of the large hydrogen plants. And as you develop the hydrogen, you need to know how you are going to store it, how you are going to transport it. So let's look at the four components of hydrogen cost. So you have the cost of generation, which we have just spoken about. There is the transportation cost and the storage cost and the loss of energy. As you convert hydrogen back into energy, you lose some of that. So the research is happening on each of those pillars, and the countries that are ahead are winning and being the global leaders and will have the first mover advantage. So it's a really big opportunity for the region to lead on this area of the future, fuel future. Okay. This is a very nice slide. It shows us like where is the cost of hydrogen today. It is at around, on average, it's around at 5.5 to 6, a little bit more to generate it. The green is generate, the turquoise is to transfer it, and the blue is to store. So we'll see that the red dots really mean what is the conventional fuel competitor to us. So the conventional fuel today is cheaper than hydrogen. So why everyone is racing for it? Why everyone is investing in hydrogen when it is really much cheaper? Really believe all the commercial entities and scientists are believing that within the coming 10 years, this cost is going to drop significantly to this white dotted line. I hope it's clear. And the hydrogen energy is going to be cheaper than conventional competitors like fuel, like gas, and so on. And the cost of competing energy is really different from one transportation means or heating means to the other. I've picked here the most low-hanging fruits that we believe in the coming 10 years are going to be really competing with hydrogen. And this chart shows us that in 2025, we will start to see this dotted line. We will start to see rail, trains powered by hydrogen replacing conventionally powered rails. And heavy-duty trucks are following. We can see on the news some trucks are being now developed by the Chinese and Japanese that really replace. Also, General Motors is putting a lot of effort into that. So we're seeing a lot of competition, and so on and so forth. We can see that it's going to take a while before we see the smaller cars being powered by hydrogen. Toyota's car now is like 3 times more expensive than the normal car, but it's being supported by the government. Why is it supported by the government? because they want to be the first mover and have the global lead on hydrogen-powered car. So as we just said, at different points in times, many of the users of energy will be deciding to replace their conventional with hydrogen as the cost of hydrogen goes down and down. We will see it's a clear hanging fruit that the buses are going to be replacing conventional fuel with hydrogen. Later it's going to be with the ships, and then later with the trucks, and then a little bit more with the high-grade industrial heat, and so on. So how do we, as a region in the Middle East, where do you see that we can enable ourselves to compete in this race? Everyone is starting this race. We want to take part of it. There is part of that race that needs to be related to the innovation. So with respect to generation, transport, storage, and lots of it all require innovation. But let me tell you that innovation alone is not enough. So for transportation and storage, these are the biggest hurdle to to selling whatever hydrogen is generated. So we really need to invest as governments here in the region into an infrastructure that can aggregate the gas from the producers and sell it to the outside world or to the local markets even, to start to enable this business. I would compare this. I will give you a nice analogy from history. The German feed-in tariff system in the 70s bought expensive electricity from solar panels in the 1970s when solar was much more expensive. And thanks to that sort of subsidy or financial instrument and laws, that Siemens and the likes of Siemens were able to improve their R&D and improve the efficiency of solar today to where we have got it today. So there has to be some sunk cost by the government, some investment, and some laws that enable the development and the innovation in this sector. So we're in the race. Of course, you will see that the opportunity is very large, but to unlock this opportunity, we have to invest in infrastructure. We have estimated on a high level what could the GCC need in terms of infrastructure for hydrogen, and it's around 445 billion. And that's really, it is considered to be expensive infrastructure if you think about it, compared to alternative infrastructure that will be 1/4 or less. So that's really the lost opportunity to us is around 300 billion. Why would I, as a government, be wasting people's taxes and people's money to invest in such infrastructure? Because if we are the first mover, we have the first mover advantage. You have neighboring markets that can amount of up to 80 billion per year, which in MPV terms is around, if we take a shorter term of infrastructure, it's around 800. In social terms, this is 2.4 trillion US dollars. So really the economic return on investment in this leading technology is worth really having a closer look and studying it. Other nations are investing in these 4 pillars of hydrogen. We have nations that are investing in the generation. France investing a lot through Total. Portugal is investing, is having a trial plant which is around 100 mega. Australia is trying to have the lead. Egypt from our Middle East is building a large plant of, planning to have a large plant of hydrogen. And Germany and Australia have signed a hydrogen accord where they exchange technologies and exchange markets. Imagine Germany buying hydrogen all the way from Australia and exchanging hydrogen from there. We are much closer to Europe than Australia. So, and the transportation, as I said, Japan has have a complete hydrogen strategy. Korea the same. Australia is trying to lead the markets very aggressively. In terms of exporting, Norway is leveraging an existing pipeline with Europe, the existing gas pipeline, to try to develop the hydrogen technology and sell gas in the future, hydrogen gas to Europe. Similarly, Turkey is trying to do the same, and Russia. So all those companies who are originally selling gas to Europe will now try to be selling hydrogen to Europe instead. And again, the Germany-Australia Hydrogen Accord, which also encourages investment in transportation. And then the storage, again, Japan, Korea, Australia. We have the Total Haisco Alliance, which really invests focus on the storage. And then the investment in the loss, of course, which is done by Honda and Toyota, Hyundai, Land Rover, and General Motors, who are also investing in locomotives. When the planes, we have Boeing and Airbus both investing in hydrogen technology. I think this brings me to the end of this presentation, and I'll leave the floor back to you, Dr. Salim.
Thank you, Mr. Mohammed, for your fruitful presentations. It's very interesting. And we move now to the discussion panel that we have. We can you stop sharing, Mr. Mohammed?
Yeah, sure.
First, I would like to apologize that our agenda shift to 20 minutes about we are supposed to finish, but we have one question to each speakers of you. We would like to have like 2 minutes of answer so we can finish earlier than better than we get more late, much more late. Dr. Abdullah Nasser, you mentioned about the importance of applying the APR. And when I imagine about it, especially for the renewable energy projects, we have like a lot of PV panels are going to be installed in GCC after 15 years and 25 years. Our countries will be like full of PV panels. I'm not sure they have applied the APR. What do you think? I think what's the situation after the 25 years if it is not applied the APR? And for your experience with the GCC and the MENA region, the political situation will help the scientists to move for better waste management or not?
It's mean I can tell you the ABR will come in all the country in the next 5 to 10 years, and will come for packaging, will come for electro waste, will come for solar panels, yeah, and only with this solution we can really find way to finance waste management. I know from Saudi Arabia started in it's mean to think about the ABR. We know it's mean for the reason really I told you I invest more than 20 years in education and waste management, and we need educated people and the decision maker to make the decision. That's not easy, believe me. It's mean to think about ABR or about hydrogen and so on. Really, we need new generation, yeah, to make this decision for the future. So, but for sure, I can tell you, all the countries will have ABR for all this kind of product in the next 5 to 10 years.
No, thank you. Now we'll move to Dr. Rami. Dr. Rami, I like the way that you talk about the AI and to get in charge with the KPI to do the strategic planning and so on. And this will be like the core of designing and creating sustainable systems. But many people think if we rely more on AI, that will lead many people to lose their job, or the job opportunity will be like get lost. What do you think about this? Do you think there is a negative relationship between these two, or it can be like managing, يعني we can get it like integrated together? What do you think about it?
Again, and as I said in the last conference for future foresighting in the World Economic Forum, there is nothing called AI will be a substitute or the right and efficient substitute of a human being. We need to learn we need to relearn and re-identify the human being competencies. We call it competency assurance management system. If we will be able to re-identify the human being competencies, it will be fit and aligned with the machine capabilities in order to reach the super efficiency or the required efficiency to accelerate the human being transformation or the human being development or life cycle development. So there is nothing called the machine will come and take my job. There is something that we need to identify. If I don't acquire the right competencies to deal with the machine and to deal with the smart life that we're gonna face, the machine for sure will be more efficient for businesses and for life, and that's exactly the case. So and this is a very crucial point, by the way. Many countries, they realize that, and they now start a program called International Artificial Intelligence Driving License. It's same as ICDL in the 90s, to acquire this main competency to their DNA. But some other countries, they still struggling to get such competency into their DNA and into their ecosystem.
Thank you, Dr. Rami. And now I have questions for Mr. Robert. Robert, and we appreciate what you present of innovations, ideas of renewable energy applications and the storage. Especially the one that you mentioned, the energy recovery hydropower. And some people are calling it like end pipe energy.
Yes.
Yeah, and for our countries, we have like more than 100 kilometers of piping that have flowing of water for long distances. I think these ideas, it's very crucial to think about it seriously in Kuwait and some other countries, since we have long distance, and also we have like water tower to control the flow. I know there is you have many inventions in this area, especially the energy storage.
Mm-hmm.
Can you tell us about it and how far you have? Okay. Now, yeah, can you tell us about your idea of your invention in energy storage, and how far you have gone with it?
Well, we're not using hydroflow in our energy storage device. We're using the pressurization of oil, which is a non-compressible, but we're compressing pressure into tanks and then letting the oil flow on demand into a hydraulic motor that will use both the high pressure and low pressure oil to mix in a way that only generates exactly what the demand is. I always try to create energy in an on-demand situation. So we're never just creating lots of energy and then only using part of it. the powering of these small hydro recovery devices can be in every building, on every pipeline, in every factory that uses water. So it could be a major contribution to energy production on micro scales. It's not a hydroelectric dam. It's not even a pumped hydro, but the accumulation of 100, 1,000 of these systems across a city or across a country can contribute greatly to the amount of electricity that can be put back into the grid and take the strain off of other sources of power. It can be used to light city streets. It can be used for all sorts of things. Our system that we're working on is less capable of being used in individual buildings, but because ours comes in a tractor trailer container size of either 20 or 40 feet. But ours can be placed anywhere that power is being produced by renewable sources like solar or wind. And we can store that energy for unlimited amounts of time without degradation and then output it in an on-demand capacity. And I think that is the really important part of any renewable energy storage system, that it is instantly available on demand and not in a wasted fashion. That brings me back to that other system that I was discussing, which is the gravitricity system, which has some excellent upsides. There's a couple of downsides to it, but they're not dramatic. You don't want to place those shafts anywhere where you might have seismic activity, because if the shaft gets ruptured in any way and it causes the piston not to be able to flow easily in the shaft, it jams in there, it ruins that particular system. But if there's limited or no seismic activity, then this is a wonderful system that I think is really attuned to the new sustainable city energy ethic. It has the ability to be built under every building, or it has the ability to be built under the city itself in hundreds of areas, and take all of the renewable energy, let's say from pumped hydro or the micro hydro recovery, and lift those pistons and store that energy. So you have these multiple systems working together to provide a backup or an alternate to creating energy from regular coal plants or anything else, which are very wasteful, very wasteful. But to answer your question, you asked at first, where are we? We're still in the research and development. We haven't raised funds to build a prototype yet on our system, which I did not show in this example because it's not something that would be ready for several years at least to demonstrate. But I appreciate you asking me about it.
We wish good luck for you. I know you have many inventions in different areas. And also, it's a good idea if you think about invention to get advantage of the heat from the incinerations power plant from the waste, as Dr. Abdullah Nasser mentioned. There is a lot
I
of...
was looking at that as he was talking about that slide, that only a very small fraction of the energy, the heat energy, was being used to create electricity to actually run the plant, but a large section to the right of the slide showed fairly high energy output and heat that wasn't being used for anything. So yeah, there's probably some some very large possibilities for co-opting that heat into an energy system.
Yeah, thank you, Mr. Robert, for your participation. Now we have a question for Dr. Mohammed Al-Haj Hussein. Dr. Mohammed, you mentioned a lot of advantages of green concrete, and you mentioned only Dubai and Saudi Arabia, they are using and they are applying this concrete. Do you think why it's not applied in Kuwait and other countries, since it is cost effective and eco-friendly? This one part. The other part, since you are taking taking the natural porcelain from the from the land, doesn't that affect the environment in one way or another?
Okay. And now the country are using natural porcelain. This is the natural porcelain. They are using now in Yemen, Syria, Jordan, Saudi Arabia, Algeria. In the Gulf country, all they are using fly ash from outside or slag. So the green concrete use local material, not outside material. So we can use like this one here, red brick, like China wall. We can use ceramic like Aga Sofia. They are using anything with natural porcelain, we can use it. But we are hoping that in Saudi Arabia, now only in Jeddah, Mecca, they have some project in green concrete. But in Dubai, Abu Dhabi, they are using all important porcelain. If they use local porcelain from Saudi Arabia, will save a lot, you know. And we have, like you said, 2,000 mountain in Saudi Arabia, 500 mountain in Sudan and Yemen, and they have mountain, 400-meter height, and every time they throw it away to make landscape. So instead of throwing away, in Palestine, they are, and in USA, in Vancouver, in California, they are selling this one with $15. In Saudi Arabia, 1 ton is 10 riyal. So in the future, I sent to the Crown Prince, if we can make, agriculture, landscape, beauty product, healthy product using, from Red Sea project, from new Red Sea project now, Amara, they are using from outside. We need to look, mashallah, in Syria, they stop using OB cement. They are using only local green cement, the only Arab country. In Jordan, they're reaching 50% porcelain. In Yemen, Syria, 35. We hope that we like in USA, 100 projects, they are using 50% more porcelain. But we have committee in ACI and ASTM, and sometime EBA or environmental protection in USA come to sit with us, and we try to we make study in USA 1 year or 2 years before the mining. Did you hit anything in environment? Did you hit any bird? Did they have any side effect on the bird or the animal? And try to reduce the impact. Try to help the people to make landscape for them by your porcelain, to give some gift for the school, to build something green concrete with the school, or make landscape using local porcelain. MashaAllah, in Japan, they are buying most of the lava in Vancouver, Canada, California. They are using for Philips and National and TV and computer. So you can sell it 10 riyal a ton or $20,000 a ton, depend on the final product.
Okay, thank you, Dr. Mohammed. Now we reach to Mr. Mohammed Mnemni. Mr. Mohammed, like 4 years ago, I read the article from one of the European researcher. He was saying that he was like talking to Arab countries. They are encourage them to make infrastructure for the hydrogen in the cities. I was like, oh, what's that? He said, you have to do that because, the European cities are crowded and they are not going, it's hard for them to make it. But the chance for Arab countries, especially the GCC, since we have a wide area to apply the infrastructure for the hydrogen. This is very interesting for now I knew better and deep what did he mean about it. You mentioned about the generation hydrogen. You mentioned some cities and countries I was surprised that you didn't mention Saudi Arabia. Saudi Arabia, they announced about the NEOM to be like exporting hydrogen or somehow.
That's right.
Can you tell us, in your point of view, are they talking about the green hydrogen or the blue hydrogen to be, and how they can produce hydrogen? I know hydrogen can be found in nature, and or you can just do some electrolysis and so on. Can you explain this?
That's right. That's right. Sure. So basically, to start with, is yes, you're right, Dr. Salim. It's building the infrastructure. Although it might sound counterintuitive. So you have having it is a high cost, but it really enables all the innovators, the research centers, the companies that are trying to innovate in this sector to start from now to innovate. And you will be surprised. We got an inventor from Saudi University 2 weeks back announcing a very efficient a model of building a battery which can store, which is very cheap to develop and can store electricity. So we have talent in the region. We can develop. In terms of infrastructure, I'm moving into the process of generating hydrogen. Hydrogen is basically available in water. Water is one oxygen and two hydrogens. So if you break it by electrolysis, you automatically got hydrogen. And water is the most abundant resource on Earth. The other methodology of getting hydrogen is to push very hot gas, very hot steam into oil or gas or coal. So that's the blue and gray and brown hydrogen. It breaks the carbon from hydrogen and generates hydrogen gas. Now, yes, on the short term, my understanding is that Saudi will be utilizing the gasification process, which is getting hydrogen from coal, because it is more cost efficient at the moment. But once you build the infrastructure, you're really opening and paving the way for other alternative technologies, which could include electrolysis in the future, inshallah.
Inshallah.
And this is not only a plan by Saudi, by UAE. Many countries in the region here are moving in this direction. Now the oil era might be changing, and we need to be ready for that.
Thank you, Mr. Mohammed, and actually, on behalf of the Arab Union of Sustainable Development and Environment, I would like to thank you all, guys, for participating with us in this webinar. And I repeat my apology of having like 20 minutes shift of our agenda. It was really valuable presentations that we had this webinar. It's very fruitful, and I'm sure the audience are enjoying the presentations. And we hope we can meet again for the upcoming events. And we'll say thank you, and we'll see you inshallah next times. Thank you.
Thank you very much.
Thank you, Dr. Abdullah.
Thanks a lot. Thanks a lot for
Thanks a lot.
Thank you. Thank you very much.
Thank you so much. Mashallah.